Alrighty, good morning, physical science students. Today is day 2 with balancing chemical reactions. I've got a couple other equations that I'm going to work through using our 5-step approach for balancing equations. So remember from yesterday's lesson, live lesson on balancing, we're going to use those same steps. My suggestion would be for you to pause the video once I tell you which element we're looking at and see if you're able to balance that element, and then come back and play the video and just kind of keep doing that whole pause back and forth. If you are having challenges after the first 2 or 3 with still balancing them with me on the video, you need to come see me in the open office to see a different way for balancing, a different strategy for approaching how to balance equations. Now remember, the reason we have to balance our equation deals with the law of conservation of matter. That law of conservation of matter says matter cannot be created or destroyed. It can only be transferred or transformed. Basically, simple terms, whatever amount of stuff I start with, I got to have the same amount of stuff at the end, which means the number of atoms for every element in every reaction must equal. The way we get them to equal is by adding our coefficients. Those are the big numbers that we place in front of the chemical reactions. So for my first reaction here, I've got silicon tetrachloride breaking apart. It's a decomposition reaction. It is decomposing into silicon and chlorine. So that step 1 is already done for me. We already have the reaction written. Step 2 is to do your count. So remember, I like to list my letters under the arrow and then do each count on each side of the letter. This part that I'm showing here in red is my element inventory. So I can see easily on the left, I've got 1 silicone and 4 chlorines. On the right, it's 1 and 2. When you're trying to pick your element to balance, remember our general rules of thumb of not starting with our H's or our O's. Remember, hydrogen and oxygen are very, very popular, and you want to save them till the end. Well, that doesn't apply here. So I look and I see which element doesn't match. Well, my only element that doesn't match is chlorine. So I ask myself, which side needs more? I know that the chlorine on the product side needs more because it's the smaller of the two. So I got to figure out what is the least common multiple between 4 and 2. Well, this is one of those times where I don't want to do 2 times 4 because that's not going to give me the least common multiple. My least common multiple between 4 and 2 is 4. So once I find that least common multiple, I ask myself, what times my subscript will give me that least common multiple? So the what is the coefficient. So what times 2 will give me 4? Well, my coefficient needs to be a 2. 2 times 2 gives me 4. I now have 4 chlorines in this reaction. Notice I didn't need to do anything to any of the other substances in this reaction. So if I don't have a number in front of it, it is understood to be a 1. As a chemistry teacher, I do not care if you come and write the ones or if you leave them as invisible understood ones. It is just important to know that when you don't have a number, whether it be a coefficient or a subscript, that is assumed to be one of them. So let's look at one that's a little bit harder. We still, again, step 1's done for me. We have our reaction. Step 2, we do our count. So Na and O. I list them on each side. So 1 sodium, 2 oxygens. 2 sodiums, 1 oxygens. Okay, well, now I got to pick which element I'm going to select first. It really doesn't matter, but general rule of thumb, save your H's and O's till the end. So since I have an O, I'm not going to start with it because I want to save it till the end. Therefore, I'm going to start with my Na. I look and I see that, okay, well for Na, the left side needs more. My least common multiple is a 2. So what times 1 will give me 2? 2 has to be the coefficient. That coefficient only affects the sodium. It does nothing to the oxygen because it's separated by a plus sign. All right, well, now let's go and fix the oxygens. So we were looking at trying to fix our oxygens, and we noticed that, okay, it's the product side that needs more oxygens. My least common multiple between 1 and 2, again, is 2. So what times, remember that invisible 1 beside the O, what times 1 will give me 2? Oh, I need to put a 2 as my coefficient because 2 times 1 will give me 2. Now that 2 not only changes the O, but it also changes the Na. So 2 times 2 now gives me 4 sodiums. And this happens sometimes. In the process of fixing one element, you end up breaking another. And that's okay. We just go about balancing the equation. So now I've got to come back and I've got to fix my Na. Now, since I have a number here, what I'm going to do is I'm just going to erase it for a moment. And I'm going to go back to the beginning. And I'm going to find my least common multiple between the 1 and the 4. So I need both sides to equal 4. I need 4 atoms of sodium on the reactant side, on the left side. So what times 1 gives me 4? Well, 4 times 1 gives me 4. So for this reaction, my coefficients are 4, 1, and 2. So we've got to remember to always check our coefficients, make certain that they are the smallest ratio of atoms possible. This is why it's important that you know that that is a 1 there. Because if I were to just pay attention to the 4 and the 2, I'd go, well, they're both even. Not with that 1. So they are the lowest possible ratio from our coefficients. Therefore, this is a balanced equation. So let's look at one that's a little bit harder. Again, start by doing your element inventory. You list your elements out and you do that initial count for the number of atoms for each side. You have to show your element inventory, ladies and gentlemen. Ms. Rains is expecting that you show your element inventory. You're welcome to type it or write it and upload a picture. So let's go and fix this one. My general rule of thumb tells me I don't really want to start with my H. Therefore, I'm going to start with my N. To fix the N's, well, we look on our product side and we see that we need more N's on the right. So I know I want my N's to equal 2. I need 2 N's on each side. So what times 1 will give me 2? Oh, it's a 2. My coefficient is a 2. That 2 changes the N's and changes the 3's, the 3 H's. So it also multiplies this coefficient. It is important when you have a compound and you add a coefficient that you recount everything in that compound. So we not only have 2 N's, but we have 6 H's. So now let's finish fixing our H's. Well, I've got a 2 and a 6. My least common multiple is going to be a 6. Which side needs more? Well, the reactant. The left side needs more nitrogens. So what times 2 will give me a 6? 3 times 2. Change my inventory to show that it's a 6. Since I didn't put anything in front of the H, it's understood to be a 1. My coefficients can't simplify, and in the previous 2 examples, I forgot to double check myself, and that is a good practice to get into, so let's double check ourselves. So 1 times 2, 2 N's. 3 times 2, 6 H's. 2 times 1, 2, 2 times 3, 6. My atoms match. This is a balanced equation. Like I said, my coefficients are 1, 3, and 2. You don't have to write the 1, but you can write the 1 if you want to. Alright, so this reaction is a single replacement reaction. We've got an element swapping places with another element in a compound. Even though there's more letters, it's not any more challenging. The process is still the same. We still do the same 5 steps. Step 1, have the equation. Done. Step 2, do your inventory. So my initial inventory, I've got 1 of everything on the left, and on the right, I've got 1 Mg, 2 H's, 2 Cl's. So we've got to figure out what we want to balance first. General rule of thumb says don't start with your H's and O's. So therefore I'm going to start with my Cl. I need more chlorines on the left side. Therefore the coefficient has to go in front of the compound that has the chlorine. We can only put coefficients in front of the compound. You're not allowed to shove numbers in between letters. That is a no-no. Coefficients have to go in front of the entire compound. So in order to fix my chlorine, I need to put a 2 in front of the HCl. I now have 2 chlorines, but I need to make certain I recount both things. So I also have 2 H's. So nothing else is unbalanced, which means all of these other coefficients are 1s. I check my coefficients. I think that's step 4. Make certain they can't reduce. They can't. Last step, double check, make certain your counts are correct. 1 times 1. That one's good. 2 times 1. 2 times 1. Product side, my H's, 1 times 2. Product side, my magnesium chloride, 1 magnesium, 2 chlorines. Okay. So my last 2 examples are a little bit more challenging because last one has more elements. And next to last one is just not your typical balancing. Most of what you're going to see is similar to what we have already seen between yesterday and today's examples. So, example number 5. Example number 5. Remember that whenever you have the same element on the same side of the equation, you have to add those atoms together. So when I'm doing that initial count, on my product side, I have 2 H's, but I have 1 plus 2 O's. So it gives me a total of 3 O's. So I'm going to actually follow our steps like a normal, typical physical science student would. Well, we can see that the H's don't match, and we've got O's that we're trying to fix. Most physical science students are going to look at the fact that we have a 2 and a 3, and then they're going to try and get 6 on both sides. The problem with that is getting 6 on this product side is going to be really, really hard because we have our O in 2 different places. So that means I have to account for the O in 2 different spots. So another way to approach this problem is we notice that we only have an even number of O's on the left. Since I only have an even number of O's on the left, I have to have an even number of O's on the right. That is the only way we're going to get these to balance. So instead of trying to get my O's to be 6, what I'm going to first do is I'm going to look at the O's in the water. And I'm going to fix it so that we have an even number of O's coming from our water. So to do that, I'm just going to multiply my water by 2. Because the easiest way to get an odd number to turn even is to multiply it by 2. So 2 times 2 gives me 4 hydrogens. For my oxygens, this 2 is not multiplying that 3 down at the bottom. The 2 is multiplying the 1 O in the water. So I have 2 O's from my water, plus we have our 2 O's from the O2 originally, which means I now have a total of 4 O's altogether. So I can continue to try and fix my O's. Now I can see that I've got an even number on the right, which is a 4. So I'm going to get 4 on the left. The easiest way to get 4 on the left, we're going to multiply by 2. So that 2 gives me 4 O's, because 2 times 2 is 4. And it also gives me 2 H's, 2 more H's. So 2 times 2 is 4. So I check my counts and I can see that yes, all of my atoms balance. So my O2 must have a 1 in front of it. What makes this tricky is the fact that you have O in 2 different places. H's and O's really like to do that. That's why we tend to save them till the end. But sometimes our normal method doesn't quite work. So we got to think a little bit outside the box. Alrighty, last but not least, this is about as challenging as you're going to see for physical science. So one thing I know we haven't seen yet is numbers with parentheses. And what I want you to know is that this number inside the parentheses multiplies everything, the number outside the parentheses multiplies everything inside. I have some students who find it easy if they do a little bit of extra side notes, I guess, and go ahead and distribute that 2 in and just give themselves a love note that they have 2 N's total and 6 O's total in that barium nitrate. So same idea on the product side. This 2 distributes in. So just like in math, numbers outside the parentheses multiply in, same idea here. It's just the difference is we put ours at the butt and math puts theirs at the front. So I have 2 P's and 8 O's. So that little stuff in red is just a little extra that might help you. It's nothing that you have to do. So let's do my initial inventory. B-A-N-O-H-P. Ooh, I got O again. So I'm going to underline my O to remind me that it's in 2 places. That reminds me that I have to add the O together because it is in 2 different places. So do my initial count. Barium is easy. Nitrogen, we've already seen 2 times 1 gives me 2. Oxygen, I had my little reminder that I got to add it together. So I've got 6 plus 4 gives me 10. My H's, I've got 3. My P's, I've got 1 because there's not a number there. My product side, my H's, I have 1. My N, I've got 1. My O, I've got 3, but it's also underlined. So I got to remember I got to add the others to it. Well, I had 8 in the other one. So mental math, I have 11 O's on that side. My barium, I have 3. My phosphorus, I have 2. So we have done our initial count. This is where that general rule of not starting with your H's and O's will be a lifesaver. Do not start with your H or your O. Pick a different element to start with. So your choices are your BA, your N, or your P. Does not matter. I like to go from either left to right or top to bottom depending on what we're looking at. So I'm going to go left to right. So barium is the first thing that I see that's broken. I see that I need more bariums on the left. What times 1 will give me 3? Well, my coefficient has to be a 3. That 3 not only changes the BA, but it also multiplies my N. So I now have 6 N's. And it multiplies my O. But it's only the O's in that compound. So 3 times 6, 18, plus the 4 from the other, gives me 22. If you and mental math don't get along, calculators are your best friend. So I got 22 O's at the moment. All right. We fixed BA. Ooh. I can go to my N or I can go to my P because we want to save the H and the O till the end. And save the O till the very end. So I'm going to go to my N because it's the next thing that's broken. I can see that I need more N's on the product side. I need a total of 6 on each side. So 6 times 1 gives me 6. But that 6 not only changes the N, it also changes the H to a 6. And it changes my O. So 6 times 3, I've got 18 O's plus the 8 from earlier gives me 36. No. 26. Mental math. All right. So I look down and I see still got H's and O's mixed up, but I'm going to save them till the end. So the next thing I'm going to fix is my P. So to fix the phosphorus, my P, I can see that I need more on the product side. I need to be a total of 2, so I'm going to put a 2 here. Okay. That 2 changes my H to a 6. That 2 changes my P to a 2. And it changes that O. It's not multiplying the 22 down at the bottom. It is 2 times 4. So we still had the 18 from over here. 3 times that. And now we have to add 2 times 4. So 18 plus 8, 26. Notice my O's match. They fix themselves in the process of us fixing other elements. My H's match. They fix themselves. They don't always both fix themselves in the process of balancing, but frequently one of them will. That's why we saved them till the end. If you had started with your O, you would have ended up down a rabbit hole and may have never gotten out. So this is probably harder than what you're going to see on your physical science test. This is some of the hardest types of balancing. But notice, even though I have a lot of elements, if we break it up into our 5 steps and follow our steps and keep track of our element inventory and constantly update it, then we will be able to balance the atoms. So check my coefficients. Can they be reduced? Well, I've got a 3, a 2, a 6, and a 1. So no, my coefficients can't be simplified. Double check the count, especially with something that has elements in 2 places. So I can double check, and I can see that yes, I've got 3 BAs. Yes, I've got 6 N's because it's 3 times 2 times 1. My O's, yes, I've got 18 O's there and 8 O's there. So yes, I've got 26 O's. My H's, 2 times 3. Yep, that's correct. My P's, 2 times 1. Yep. So my product side, start with my P just because I feel like it. So my P, 2 times 1. My H's, 6 times 1. My O's, well, I had 8 from here. And 6 times 3 is 18. My N's, 6 times 1 is 6. My BA's is a 3. So especially with any that are that have larger or multiple compounds, this is a double replacement reaction. It does not hurt to double check, make certain you didn't lose track of anything in the process of balancing. That is it for today. You do have an additional practice assignment. Make certain you read the instructions in Google Classroom because I did modify the assignment after posting it. If you had challenges still with balancing, come see me because there is a completely different method that might work for you a little bit better. That is all, and I'll see you in the meets.